Let me just know whether now you can see my screen. Okay, you can?
Yes, ma'am, you can see yours.
Okay, good. Okay, so I'll just run through it. And today let's keep just a formal session just for the discussion. We'll just go through this again, okay? Later on
Okay.
sessions. Okay. So basically, if you understand flow in roofs, ceilings and floors, if you understand any of the one, you'll be understanding the rest of the two also. Okay, so let's start with floors. Okay, as you can see, you have boundary lines, slope arrow and span direction. So boundary line is basically it specifies the boundary or the periphery of your floor, whereas slope arrow, it would define just a minute, I'll just add on to, yeah. Okay, so and the slope arrow will basically define if there is any slope to your floor, you can define it using a slope arrow. Okay, so I use my rectangular, this is my drawing tool, so I'll use those tools to define your periphery or the boundary of your floor. Okay, now these two lines basically define the span direction. Okay, the main bars running, which direction are the main bars running. So you can change that using the span direction. Now this is just for in case if you're going to model your structural elements, you can have these defined. Okay, right now if it doesn't matter if you're just modeling as a 3D model just to extract without any information regarding structural. Okay, so this is how you can model it. So once I specify the boundary, I'll just finish my mode. Okay, the floor mode. You can see my floor is generated, my floor is created. I'll just make this fine and shaded. If I go now, I have made this floor on which level? It's on level 1. This is my floor type and these are the various options you can see. Okay, so these are the various family and types of floor. Okay, now if I go to the elevation of it, this is made on level 1. If I go to the elevation, if you see in this elevation, your floor is generated below your level 1. Why? Because your floor is going to be the slab of your floor under it. Okay, the level under it. So basically we know that these levels are your floor finish levels. Okay, so automatically your floor will be generated below it. Okay, that is one thing. Whereas in case of roofs, okay, so now what I do is if I select roof, okay, it will ask me where I want to make this roof. So I am saying it's going to be made at level 2. Okay, let's keep it on level 1 right now just to have a clarity between what is the difference in floors and roofs. Okay, both are going to be modeled on level 1, right? So I model my roof here without any slopes to it. So I'll just without any slopes to it, I've modeled this level roof. Okay, I close it. Both are modeled. Now if you go here and you can see this is my level. The only major difference is your roofs are modeled above the level, specified level, whereas your floor is modeled below the specified level. Okay, that is one major difference between the two. Okay. Now when you're modeling it, always remember if you have any cutouts etc., so you can make those in the edit boundary itself. While you're making your boundaries, you can specify those. So if you have shafts, if you have lift shafts, if you have staircase shafts, okay, or you might have different floors, okay, sunk slabs etc., so you can make those while you're modeling the floor itself. Okay, so you can always use shafts as an option for any cutouts, but what we usually do is we model it in the floor itself. So I can go to edit boundary and imagine if I have a cutout here. Okay, I have a cutout here, so I'll just use my boundary and model it accordingly. So now this is my floor slab and this will be my cutout. Okay, and I end it and you can see you can get a cutout. If I create a section, okay, and I have my fine and shaded define, I'll just off my line weights and you can see this is the floor which is cut. Okay, so that is how this is seen in elevation. This is the floor which is cut. Okay, so likewise you can create different floors as well. So if imagine if you have a sunk slab here, this is at level 1 and you have a sunk here, you have your toilets here. So what you can do is, I'll create another floor, right? Because your sunk slab is below that specific level, I create a floor. Okay, and you can create a new sunk slab type floor, okay, with all your finishes, or else you can use this floor and give a offset to it. Okay, so I create this and I can give a height offset from level 1. So if it's below level 1, mine is 450. Okay, my sunk is 450. So I'll just specify it, and this is how it gets created. Okay, if I go to section, this is how it will get created. Now here automatically your beams come, so they get connected. Right now we are just modeling your slabs. Okay, so this is how you can actually model different slabs in different levels. Okay, now this is how basic modeling is done. Okay, now let's check the properties of each and every floor. So basically, if I select a floor, we already know these are your instance properties. So in your instance property, first of all, the family and type. Okay, so these are the various families. You can create your new families as well. Okay, now first in your instance property is at which level that floor is. Okay, what is the offset, if any, from that specific level. Okay, and as we know, we have to keep your room boundings on for future purposes, for advanced advanced Revit things like rooms, etc. Okay, then you have the dimensions which are automatically taken up. Okay, and then the identity data. We already know what is identity data. It's a non-graphical data, so any extra information you'll be putting up in the identity data. Okay, now let's check the edit type, that is your type properties. Now similar to your walls, here also you have the structure of your floor. So basically what kind of floor it is. So first is family and type. If you want to make any changes, create a new one, duplicate it, and I say new. Okay, so this is a new type which I am creating, and in here you have the first parameter as structure, where you'll get the core boundaries and you can formulate the structure of the slab. It's similar to walls. So if you have any finishes, okay, so I'll just insert various levels various layers. So finish layers I apply, and I can give its materials. Just a minute. Material tab takes time to open at times, at least at the first time. Okay, and here if I specify screed, so you don't have screed, so you can use gypsum board. Okay, you have cement screed, so I can use cement screed, whatever the thickness of it is. And here I can use my tiling, so ceramic tile, whatever the thickness of it is, and these are your finishes. So you can see it's added, and finishes come outside your core boundary. So I go up and up. Okay, and automatically the thickness is generated. Whether this floor, what is the function of it? It's an interior floor, or it's in a balcony floor would be a exterior floor. So that's how you'll mention its function. Okay, similar to your walls, the graphics for course level, okay, course scale, you can specify it. Structural material is similarly taken from your structure directly. Okay, and then is the identity data. So any description about it, type mark, the cost of this particular floor to construct this 1 square feet of floor, what is the cost of it total, including your labor, traveling, etc. Okay, so total construction cost for this particular floor would be specified here, and I say okay, and you can see this floor is basically generated. Now here if I go to my elevation, okay, this was the floor, I'll just go to section. This was my floor, right? And you can see, we know, as I mentioned, your level is your floor finish level. So that is why you can see my floor finishes. So my floor starts here, so it's including your finishes. This level is specified by default. But what if you have considered these levels as your structural slab levels? Then this model will be wrong. Basically, you have modeled it wrong. What you'll need to do is you'll need to have an offset for this floor. Why? Because your structural slab is only this much, right? This much. So you'll need to keep that in mind and accordingly model. So if it's considered as a structural slab, you'll have an offset of whatever the thickness is there. So it was like 35, right? And I say apply. Now this is how you're going to actually model the model basically. Okay, if this is considered as structural slab. If it's considered as floor finish, you'll have it as a default one. Okay, now in BIM environment, if you have architectural and structural as separate models, in that case your structural model will only consist of this floor, whereas your architectural model will only consist of this floor. Okay, so accordingly one of the two people will need to give an offset. If this is considered as structural slab, then your architectural architectural person will need to give an offset for your floor. Whereas if this is considered as a floor finish level, your structural model will have an offset for it. Okay, so that's how you need to keep this in mind. Okay, this is very important, and this will be important in BIM environment. Okay, for every instance. Okay, I hope you all are getting it. If any doubt, let me know. Okay, now next what we have here, we know how it's modeled, we know how it is done. Now what if we have a slope to this particular floor? Okay, so what I'll just do is I'll just delete this floor. Okay, I have a normal slab. Okay, that is a flat slab right now. What if I have a particular slope to it? So in that case, you can have use your slope arrows. Okay, so your first and second, the arrow ends need to be connected to two boundaries of your slab. Okay, and the height of it, how is the height taken? So I take this, if I go to elevation, you can see it gets a particular slope, right? Now how do you get this slope? It's basically, if you select this arrow, you can see in the properties of the arrow, it's specified as height at tail. So basically you have the tail and you have a head. Okay, so at tail it's 300 from whatever level we are modeling. So this is known as the tail, this is known as the head. So at tail it's 300, whereas at head it's 0. So if I make this as 1500 for better understanding, and I end this, you can see this is your tail. Okay, so this is how you can get your slope. So this will this can be, your floors can be used to model your rams, etc. also. In some cases it depends on various situations. Okay, so it is not a compulsion that ram needs to be modeled using a ram. It can be modeled using a floor, but it will matter in what situation you are modeling it. Okay, what are you actually going to do with it in future? Okay, that's how this modeling would depend. Okay, now if you say we know how to add on slopes, but what if right now what we are doing is we are just giving an arrow and we are specifying a certain slope, but here the whole slab is being sloped at one direction, right? And you cannot specify a single point, or else you cannot specify a point where all every surface comes and joins there. Okay, so in that case Revit enables you to basically create such slabs by having an option which is known as modify sub-elements. Okay, so when I select a floor, you can see you get modify sub-elements. What this allows is, it basically you have 4 vertices, so you can specify each vertex a different height. Okay, So if I say modify sub elements, and you can see each vertex gets a point, so you can specify each a height. So if I say 1500 at this point, this is minus 1000, and this is like plus 500. Now if you see this in south, you can see orals are 3D. You can see each vertex has a different height. So this is how it allows you to make it flexible, to have a floor which is flexible. Okay, not only this, but this you can add on different points. Okay, so basically to reset this shape again, to make it flat, just have reset shape option. Okay, it's flat, back to flat. Now in modify sub elements, not only you can specify different heights for your vertices, but also you can add on different points and line. Okay, and specify a height to it. So if I say I modify sub elements and I specify I have a certain point, so I have here somewhere I have a point, okay, which basically every like the whole slab is sloping towards that point. So I specify this point, okay, and I specify the height for it. So if I say this as 1500, okay, and you can see it in 3D, your slab is sloped accordingly, and that point is the center. So the whole slab is sloping towards that point. Okay, similarly, where can you use these? Any idea? Basically these can be used in your baths, in your toilets, etc. You have the nani traps, etc. So you can use these there. Okay, so if I say this as minus 500, also you can use this at terrace levels, etc. Okay, so this is how it slopes. Okay, similarly, not only a point, but you can specify a line, and you can give it a specific height. So I say modify sub elements and I add a split line. Okay, and here I can specify a height to that specific line. Okay, and you can see this. So this is how it allows your floor to be flexible. Okay, so basically modify sub elements can help you in various manners. Now in this, okay, now in this, if I have a section, okay, what is happening here is, if you see carefully, not only your floor, that is your finishes, but also your floor is sloping. The whole floor is sloping here, right? It's a slant slope. But what if like in your sunk slabs, when you're having your sunk slab in your toilets, is the whole slab sloping? No, your slab doesn't slope, your slab is flat. But when you provide a nani trap, how do the whole slab slopes towards the nani trap? It's because of the brickbat cover, that is the waterproofing layer, right? The sunk, because of that. So how do you actually modify those? Okay, so your this is going to be wrong. So your basically your structural slab would be straight, and whatever the filling is, that is what is going to be varying, right? So in that case, what you need to do is go to edit type, okay, and imagine this is your sunk slab filling. Okay, now this is the filling, because ceramic tile will have a fixed thickness, your structural slab is going to have a fixed thickness. But is your brickbat cover going to have a fixed thickness? No, because it's a filling. That is where you actually vary the slope. So here you will need to make this layer as variable. Okay, take this as variable, then this layer is going to vary its thickness, and I say okay. Now you can see only that specific layer is varying the thickness of it, whereas the tile layer and your structural slab level is going to layer is going to be the same. Okay, so this is how actually you model your sunk slabs, etc. Okay, and this is how you make it variable, the layers variable. Okay, understood? Clear enough? You need
Yes,
to
ma'am.
you need to make this variable. So this is going to be very important. Why? Because while extracting your material takeoff, material data, you'll need to keep this in mind. Okay. So if you have any sort of material takeoff, if you have not made it variable, your whole slab is going to slope. And if it's a very minute slope, you won't even have it won't even be seen, but that is going to affect on a large scale project. Why? Because the material takeoff would affect. Okay, so that's how precise you need to be. Okay, so this was basically your floors. Okay, now if you understand floors, similar to floors you have roofs and ceilings. The only difference we know here is floor is basically your slab, that is your slab for the lower floor. Okay, whereas roof is actually a roof which is modeled above the particular levels. Floor is modeled below the particular or the mentioned level. Roof is modeled above it. Okay, so here you can just delete this. So I use roof. Okay, at which level it is asking. Even if I am on level 1, I need the roof at level 2. I say okay, and I specify the roof. Okay, now by default what will happen is, this is how the roof boundary comes in. I say okay, and I go to your elevation, and this is how at level 2 these are your family and types. Okay, so this is how your roof comes. Okay, comes up, is modeled. Okay, now why is it taking a slope? Because by default in Revit your roof has a defined slope. Okay, so what I do is edit my footprint. Okay, it's on level 2. Okay, so if you see, when you're making the boundary, you get these small triangles. Okay, what are these triangles? These are basically defining the angles. As you can see, if I select it, so if I select this and if I change this angle to 60, okay, this side to 60, I go to 3D, and if I say I tick this, you can see the slope has changed. Okay, so this becomes your 60 degree, this is 45, this is 30, this is 30, this is 30. So it basically, you're defining the angle of that particular side. Okay, that's how you model a roof by default. Okay, but now what if you don't want a sloping roof? You have a pyramidal roof, I mean, so you have a normal flat roofing or a terrace as such. So what you do is, when you're modeling, one way is by selecting it, making it 0. The easiest is select the whole thing. Okay, and here you have defined slope, roof slope. You can tick this off, or else you can tick it from here. Tick this off, automatically it's gone. And when you tick this, you can see in 3D or else elevation, it's a flat surface, flat roof. Okay, it is, the category is still roof. Okay, similarly also while making a roof, okay, I delete it. When I'm making a boundary, you have this option, so you can just tick this off and you get a roof. Okay, so this is how basically you model a roof. Okay, now similar to your floors, here also you have the modify sub elements. So for your ridge, in case of your terraces etc., you might have ridges and valleys for your rainwater harvesting etc. So these tools, the small tools, are going to help you to do that. Okay, if you see the properties of it, similar to the roof, similar to the flooring as it. So you have the base level, the room bounding needs to be on. Okay, and the identity data is what you need to keep in mind. Okay, that's all you need to focus mostly. Okay, then once you go to edit type, we know the structure of it, similar to your walls and roofs etc., walls and floors. You'll have the structure of the roof here, and then you have the pose patterns, that is for your graphics, and your identity data. Okay, any description, cost of it etc. Okay, so this is how actually you model a roof. Okay, now here also you have the same thing, same command for slope also. Okay, you can define a slope here by using the slope arrow also. Okay, Understood? So this is basically how you model your roof. Okay, now in your roof, this is how basically you model a roof. Now next what comes up is your ceiling. Now what is the difference between roof and ceiling is, ceiling is basically used as a false ceiling. It has a default height to it which is acting as a false ceiling, and it is the category of it also is ceiling. Why is it differentiated? Because if you're modeling an interior model, okay, there are many interior components, like we have normal components which tend to have the host as ceiling. So just like we have door and windows whose host is a wall, similarly there are some components like that might be your light fixtures, etc., which have the host as ceiling. Okay, that is why you have a different category altogether. Okay, so if I say ceiling, okay, and you can say sketch a ceiling, and this is the same thing as you can see as roofs and floors. Okay, so I specify the ceiling level. Okay, if you have a band which is there, okay, for your ceiling in interiors. Okay, and if you go to your elevation, you can see the default height, it's on level 2, the default height of the ceiling on level 2. I'll just make it on level 1. Sketch. Okay, so this is the design of your ceiling, whatever. Okay, now if you see this, the default height here is 2.6 of your ceiling. You can vary it in your instance property. Okay, also you can see similar to slab, it is getting cut. Also if you see the structure of it, you can see the category here as it is categorized as ceiling, this element. Also if you go to edit type, in your edit structure you can see this is how the ceiling layers are defined. Eventually this can change according to your ceiling material, whatever the ceiling you've used, whether it's a gypsum board ceiling, whether it's a wooden fall ceiling. Okay, so you can define it likewise. Okay, so this is the structure of it. So that's how ceiling varies. Rest everything is the same as floors, ceilings and roofs. Rest everything would be the same, the components and properties. Okay, only the category is what will matter most. Okay, understood? Any doubt? You can have different heights here as well. Okay, so basically any doubts between roof, ceilings and floors, anything, or eventually when you practice you'll get it, but anything right now you can ask me. Okay, anything?
No ma'am.
Okay, cool. So now what we'll do is we'll further start.
Ma'am, what is the cutoff level in now?
Sorry, what if?
Cutoff level in properties in the roof. What was the cutoff level in properties in roof?
Okay, basically, see, usually you don't change those things. Okay, these ones. That is because the roof type is what is defined here. So now here if you see the construction rafter cut, right, it's plumb cut. Usually you don't need to change it. Why? Because that's the default one, and this construction type is not going to matter right now. Why? Because you're not specifying any rafters, etc. And if you model the rafters and all, you use your structure, you can use your beam systems, etc., which will make it easier for your modeling and change it to different materials. Now similar to that, because of that you have this cutoff level. Cutoff level is basically defined where your roof gets in your I can say, okay, now what happened is right now it is none. Okay, and this was a flat roof. So what I do is I'll just take a sloping roof for it. Roof. Okay, here I'm specifying which level 1. On level 1 I'm modeling my roof. Okay, and I'm defining the slope zone. Okay, the cutoff level here, now this, okay, the 30-degree angle here. Okay, this angle defines a slope. Okay, now when this angle is defining a slope, it is basically defining the angle of that particular length, or I can just go to elevation. Okay, now it is basically defining this angle, right? Now this roof needs to end at which level? That is the cutoff level. Okay, right now it's none, so whatever the angle is, it would take. Okay, so if I define level 2, you can see at level 2 the cutoff is ending. Okay, the roof ends here. Okay, if I change this in your edit boundary, if I change these angles, okay, from 30 to 60 degrees, 60 degrees, okay, and if I go to elevation here, right now it's ending at level 2. Why? Because my cutoff level is level 2. If I say none, you can see it goes up where? It goes to level 4, above level 4. If I define it as level 3, it will cut my roof at level 3. So that's where it will model, and it will give a flat surface at that level. Okay, basically that's how it is cut at that level. Okay, and then you will have to model a separate roofing which is flat here. Okay, that's your cutoff level. Understood?
Okay.
Yeah. Now we come up. Okay, I'll just do this. Okay. Okay. Now roof, ceilings and floors are done. Now what we come up is your ramps. Okay, we'll come to circulation spaces. Staircase would take a bit of time, so I'll just keep that aside right now. I'll just go with the ramps for today. Okay, so what is ramps here? How do you use ramps? So now, as mentioned earlier while doing floors also, you can use floors for modeling your ramps, but what matters is in what scenario or in what situation are you modeling this. That is, there are some situations where your ramp command won't be useful to model a ramp. You might use the floor command, or else you might use a roof command, or also you can use is your components. Okay, model in place, which will be seen. Okay, so that's how different situations would arise, and you'll need to decide. Now that understanding of what command are you using to model that specific element would come only after you've you've done 2 or 3 projects on it, okay, in Revit. So you understand what can happen in future with this element, okay, if modeled with ramp, if modeled with floor. So that level of understanding, but by default you have a ramp option here. Okay, so once I select ramp, you can see this is the type, family type you have in ramp. You can create a new one. Okay, now you can see the modifying tools, and here what you have are the modeling tools for creating it. Okay, so your first option here is your run. What is run is basically it directly creates a ramp. Okay, you just need to specify the path for it. Okay, whereas boundary and riser is used to sketch a ramp. Okay, when there is a flexibility or as you have a different kind of shape to a ramp, you can use boundary and riser for it. Okay, so first let's see run command. So in run command, what you have is a line and a arc. Okay, you can use these 2 commands to basically specify a path. Okay, so I use my line command here. Okay, now here you just remember, whenever I am making a ramp, okay, you have the base level and you have the top level, and if any offsets you can specify that, okay, for both. Now when I make this, okay, as you can see I cannot go further 12 meters. Okay, why? We'll see that, but you can see I cannot go beyond that, and I end my ramp, and I've specified it goes from level 1 to level 2. Okay, now I go to south elevation, and if I end this, you get an error here. What is the error? The ramp is not long enough to reach the top constraint. Change the slope or increase the length of the ramp. That means the ramp which we have provided, the 12-meter ramp, won't reach level 2. Why? Because one thing is the slope is not good enough. If you increase the slope, it might reach. but if you don't want to increase that, you at least need to increase the ramp length. So instead of 12, you might need more length for the ramp. Okay, so we know that. So that is why it is not allowing, that is why this error happened. So basically with the same ramp, how do you extend it? So when you make the first ramp, which was 12 meters, okay, by using run itself, okay, now this is my ramp, then you have a flat land, that is a flat mid landing, okay, and the next ramp starts here, and I say again here, then again a flat mid landing, again a ramp. So basically, why is this mid landing even? Similar to any staircase, after any flight, okay, so after 10 steps or 11 steps, you have a mid landing. Why? Because a person cannot, it's not feasible for a person to climb a single flight which is more than 10 to 11 steps. It would basically tire the person. Okay, so that is why usually we have mid landings after 10 to 11 steps. Okay, similarly in ramps are basically made for whom? They are for the specially challenged people. So it's like for the wheelchair people. So in case of that, can a wheelchair person travel a particular ramp which doesn't have a mid landing, like for like 50 meters in a row? No, you cannot. Okay, by any slope you cannot travel. So that is why after 12 meters you have a mid landing. After 12 meters you have a mid landing. So it can vary. After 10 meters, after 12 meters, you can give a mid landing. You need to specify a mid landing. That is why you need to have a mid landing in this case. Okay, so when I specify this and I finish over, okay, as you can see, I didn't get any error here now. And if I go to an elevation, you can see automatically the ramp increases. Okay, so that's how you reach your level 2. Okay, this is one option. Okay, how? By increasing the length of the ramp. The second option here, what you have is by increasing the slope of it. Okay, so I'll just delete this ramp and I create another ramp by using run. Okay, and you can see I cannot go above 12. You can go below it, so it's like 4,000 and again 12,000. So I can go below it but not above it, and I tick this. You can see again the same error. Why? Because it's not reaching that level. Okay, so I create 12,000. Okay, so where do you actually change the slope? And why is that 12,000 maintained? Where is that specified? Okay, so basically that is specified in the type of that ramp. Okay, so this is your family type. So basically when you go to type properties, okay, here you can see ramp 1. I'll just duplicate this. Okay, here in the dimensions you have maximum inclined length, which is 12,000. So that is why it was 12,000 and you cannot go above 12,000. Here you can change it to 15,000 and now onwards it will be 15,000 maximum length. Okay, whereas your maximum slope here is 1:x, that is 1:12. If you increase this slope, if I say 5, okay, and I say okay, now you can see the ramp will get that slope and it went up. Okay, so this slope is what is going to matter. Okay, so that's how you'll be changing your slope. So if I say as 3 and I apply, okay, now this slope will vary according to different criterias. Okay, so if it's a vehicular ramp, it will be a different slope. If it's a wheelchair people ramp, specially challenged ramp, it will be a different slope. If it's a normal ramp, it will be a different slope. Okay, you have these rules which you need to follow according to architecture. Okay, so that's how you will be having your ramps created, and this is the slope which it will define, and this is the maximum length. Now as we've changed the maximum length, now when you make a ramp, okay, and this was the ramp which we have made, you can see the maximum slope, it was 1, I guess. Just a minute, let me check. RAM 2 15,000. There is some error, but actually it just runs up to 30 meters. Okay, so I'll just need to close the I don't know file. It happens at times, don't worry about that, but this needs to go up to 30 meters. So that's how it will reach your maximum length. Okay, so if I just change again to this as 12, sorry, and you can see it goes to 30 meters now maximum. Okay, so 15, and I can say again as 10. So this becomes your mid landing, and I take over. Okay, so that's how you model a ramp. Okay, now this was using your typical a ramp command, and you can see here in your ramp command it doesn't give you the flexibility of modeling it in a different manner, in a different shape. Okay, if you have a certain different shape according to your design, etc. So for that you get an option of by using a sketch. This was by run and this is by sketch. Okay, your boundary and riser. So boundary is basically defining your ramp, whereas riser is basically going to define your riser is basically going to define your the start and end of your ramp. Okay, and your mid landings. So here I select my boundary. Okay, and these are the drawing tools. So if I say this is one boundary, okay, of my ramp, and this is my second boundary. So this is how my ramp is basically in shape. Okay, now starts here, right? So I say riser, this is my riser, first start. Okay, and this is my end. Okay, and I take over it, and now if you see, it has created a ramp. Okay, this flexibility won't be possible in run. Okay, now similarly if you have a mid landing in between. Okay, so for that what I do is, in your sketch, by using a riser, this is your start, here is your mid landing. So I define my mid landing start. Okay, and then I define this is the mid landing. So basically ramp, mid landing, ramp, and again if you continue it would be a mid landing, then again a ramp. So this is basically where a riser defines your start, mid landings and ends. Okay, and I say okay, I take it over. Okay, once you end the command, it's generating, it's processing. Okay, once it's processed, as you can see in 3D, you can delete the railings. We can put the railings later. Okay, in sketch, and this is how ramp, your mid landing, and again a ramp. Okay, so this is how basically you'll be using by sketch. Similarly, you can make a curved angle, etc. using a sketch. Now here in its properties for your run as well as your sketch, you have your constraints. Okay, and then is the graphics. So in graphics, what is the up text, down text is basically the definition of this. Okay, now here if you have a run, okay, by using a run you have created a ramp. Okay, and I take this over. You can see this here, the width, you can define it here, and automatically it takes the width of that specific ramp. So if I say the ramp is 2000 in width, you can see it increased. Okay, this is only a property for your run. Okay, because by sketch is going to be according to your design and it's flexible. Okay, so that's how different it is. Okay, also to flip over your ramp direction, that is right now your ramp runs from your left to right. Okay, left to right direction. What if you want to flip it? So for that you have this small arrow here. Okay, you just click over and you can see it's flipped, and if you go to south you can see it's flipped. Okay, so it's as simple as that. It's not, it is applicable for your sketch as well. It's flipped. Okay, as you can see. Okay, so this is how your ramps work. Okay, now in edit type also, if you see your, okay, so for this I'll just delete this and go to south. Okay, for this, if you see your, the shape of it, right now it's thick, that is, it's like a slab. What if this is at your ground level and it's running from your ground till your plinth level? Okay, in that case this might be filled. So in that case you'll be using solid, and I apply. So the lower part is filled basically. Okay, so this is how it looks. Okay, whereas if I make it thick, what is the thickness of it? The thickness of the slab, you can specify it here. So if I say 250, you can see the thickness increases. Now what's the function of the ramp, whether it's interior or exterior? Okay, and this is nothing but the text size and font which we see for your up, etc. Okay, and then your ramp material and your identity data for that specific ramp type. Okay, so this is how you actually model a ramp. Okay, now by using sketch you can have your curved ramps, etc. as well. Okay, so I'll just try and show you one. So if this is my boundary, so my boundary, okay, then I have this, okay, just one second, boundary, and I used this. Okay, and then again this goes like this. Okay, this defines, and I give an offset as 1500. Okay, this defines my boundary. Now I define my riser, and one mid landing is your, the second mid landing would be your third. Okay, and this might be my end of the run. Okay, and I just stick with it, and you can see my ramp is generated. Always remember, you can delete this railing right now, and we'll be seeing railings, how to model it as a separate entity. And this is how you can create different kinds of ramps. Okay, understood? So this is how you'll be creating ramps for various purposes using your ramp command. Okay, I hope you all have got it. If any doubts, let me know right now. Okay, okay, so for today we'll just end the session. Roof, ceilings, floors and ramp is what we have gone through, and this was just like, because of all the technical glitches, we'll be just going through the remaining part, like the staircase and the curtain systems, in the extra session which we'll be rescheduling. For today's, we'll be making up for it, so don't worry about it. Okay, so for today we'll just end up, and sorry for the technical errors today. Okay, so any doubts regarding it, let me know right now, or else we can end the session for today. Okay.
Okay, ma'am.
Yeah. Thank you.
Thank you, ma'am.
Yeah.